5.6, the remainder theorem worksheet. So let's go through this. Use syntactic division to find f of 2 and say whether 2 is a factor of a function or not. So if you're doing syntactic division, the key thing about this, the factor, it's just like a factor in numbers. So it means you have no remainder. So the remainder equals 0. So if it's a factor, the remainder should equal 0. So if I do syntactic division on this one, so I get 1, 2, -3, 1. All I really care about is the remainder. Now we're doing f of 2, so I don't switch it because they're just giving me the straight out number. If they gave me x minus 3, I would use 3. But if they just tell me f of 5 or something like that, then you just use 5. Right? So it's very important how they give it to you. So in this case, it's 2, so just use 2. Bring down the first one, multiply across, add down, multiply across, add down, multiply across, add down. I got 11. So it's not 0, so not a factor. Like that. Let's do the same thing with this one. Now this one, if you notice, it's missing a term. x3 minus 5x plus 2. There's no, has to go in order. There's no 0x squared. So it should be 1, 0, -5, and 2. Then we have 2 on the outside because of this guy. Bring down the 1, multiply across. That gets me 2. Add down, gets me 2. Multiply across. 4. Add down, -1. Across, -2. And I get a 0. Woo! Factor. Like that. Remember anything about syntactic division? That's one way to do it. Syntactic substitution, I guess. Another way to do it is just plug in 2. So another way to do it, you just plug in 2. 2 squared minus 8 times 2 plus 6. It gives you the exact same thing. That's the whole point of the remainder theorem. So in this case, I get 10 minus 16. I get -6. So not 0, so not a factor. Remember, it's the exact same thing as doing the remainder theorem, syntactic division. If I did 1, -8, and 6 with the 2, bring down the 1, multiply across, -6, I get a -12, add up, I get 6, -6. Right, so you get the exact same answer either way. So sometimes it's better to do that, sometimes it's better to do this. The next one, I don't want to deal with those big numbers. I'm not sure if I do. I think it might should be easier just to division just because of numbers. So 1, 0 for x5, -4 for x4, 0 for x3, it'll go down in order. 3 for x2, 0 for x linear terms with this x to the first, -10. Now we're still doing 2. So bring the first one down, and all you care about is the remainder. Right, again, if I want to plug in 2, if I had a calculator, that's way easier. But without a calculator, I think this is actually easier. So bring down the 1, multiply across 2, add down 2, multiply across 4, add down 0, multiply across 0, add down 0, multiply across 0, add down 3, multiply across 6, add down 6, multiply across 12, and I get -2. So not a factor again. So that's the idea. So the next one. Create a polynomial and one of its given a polynomial and one of its factors. So here's my polynomial and here's the factor of it. Find the remaining factor of the polynomial. So I get divide. So the best way to do this is by syntactic division. So this is 1, 1, -16, -16. Now this time they give it to me in the binomial form, x plus 1. So I have to use -1, right? So they give it to me in binomial, you use opposite. Bring the first one down, you only care about the remainder. So I get 1, multiply across, -1, add down 0, multiply across 0, add down -16, multiply across 16, I get 0. Now it should work because they told you it was a factor, so I'm glad it did work. Remember, this guy's always 1 power less, so this is x squared. Skip the x term, and -16. So right now I have, if you want to factor this guy, we know it factors into x plus 1, and what I have left over, x squared minus 16. But I can factor this guy some more. Put the 2 squares. That's x minus 4, x plus 4. So that's it, completely factored. So you factor this guy by turning to those 2 things. Next one, same idea. They give us one answer and they want us to factor the rest. So we're going to do this. So 2, -5, it goes down in order. How nice. 15. Inside opposite, because it's like that. It's been binomial form. So bring down the first one, multiply across. And remember, it should work. negative 11, multiply across 33, 5, multiply negative 15, and I do get 0. And remember, this is 1 power less, so this is 2x squared minus 11x plus 5. And it wants to factor this. Does it factor? Let's see. Let's multiply these together. I get 10x squared. And I need two things to multiply to get 10, but I have to get negative 11. That would be negative 10x and negative 1x. It does factor. So plug it in. 2x squared minus 10x minus 1x plus 5. These have a 2x in common. So x minus 5. Always bring down the middle sign, which is the negative in this case. These have nothing in common. When they have nothing in common, pull out the 1. Remember, you're just factoring. Negative 1x divided by negative 1 is a positive 1x. Positive 5 divided by negative 1 is a negative 5. Hey, these match. Pull it out. X minus 5, 2x minus 1. That's it factored, and don't forget the thing you start off with, x plus 3. So that is this guy factored. Let's move on. Application number of a bald, the approximate number of bald eagles nesting pairs in the United States can be modeled by the function this. It's an ugly function, where x is the number of years since 1970, but how many nesting pairs of bald eagles can be expected in 2018? So we're going from 1970 to 2018. That is 30 plus 18, so 48 years. So they want us to do P of 48. Now you can do some division. It'll be disgusting though. So instead, how about we just put in your calculator, and if you do that correctly, you should get about 17,26725.41. About there. It's an approximation. Okay, next one. This is a lot like, this last one here is a lot like the one we did up here, where they give you an equation and they give you one factor and they want you to find the rest of the factors. But in this case, they don't give you one factor, they give you a graph. So my equation's right here. F of x equals 20x cubed minus 47x squared plus 8x plus 12. I should get three factors, most likely. But what I use the graph. See right here where it crosses nicely? This one I can see right there. That's x equals 2. That's one of the factors. It's also a root. That's a factor. That's a root, an x-intercept, and it also means it's a factor of that equation. So that's like the one that works. I know 2 is going to work. I would have done one of these, but I honestly don't know whether they cross. So I'm going to leave those blank for now because I have no idea where they cross. So we're going to do 2. That one crossed nicely. So do synthetic division. The first one down. Again, we're using 2. It's not an equation. It's just 2. So we're just going to use it. So 20. Multiply, you get 40. Add down, I get negative 7. Multiply across, negative 14. Add down, negative 6. Multiply across, I get negative 12. And I get 0. It does work. So I get 20x squared minus 7x minus 6. Now, does that factor? I don't know. Let's see. Multiply them together. I get negative 20. I need two things to add to get negative 20 back. Multiply, get negative 20, but add to get negative 7. That's another hard one. 15 and 8. You can go through all the comments in negative 120 if you want, but 15 and 8 work. 15 times 8 is 120. When you add these two up, you get negative 7. So it is a negative 120. So we're going to plug that in from the middle. 20x squared. The hardest part is finding the factors that work. Other than that, it's just easy pickings. That. These have a 5x in common. No one said 4. So I get 4x minus 3. Bring the middle sign. These have a 2 in common. So much simpler. I get 4x minus 3. Hey, these match. So 4x minus 3. 5x plus 2. And you think we're done? We're not. Don't forget the first one. It was 2, right? How do I write that as an equation? X minus 2. There you go. Last one. This is x to the 4th. So x to the 4th minus 2x cubed minus x squared plus 2x minus 24. Now, which ones do I know work? The x-intercepts across nicely. Negative 2 and 3. Now, I only see 2 that cross. That means there's only two real roots. But there's 4 roots in total. So what does that mean? You have 2 imaginary. You always have to add up to the number of roots you have, or total roots you have, complex roots. Anyway, which one I use first doesn't matter. Your choice. Dealer's choice. I'm gonna do 3, I guess. So 1, -2, -1, 2, -24. Bring the first one down. 1, multiply 3, add down 1, multiply 3, add 2, multiply 6, add down 8, multiply 24, and it works. 0. Remember what happens when you do this once, right? You went down a level. So I'm not going to use this. This is done for me. It went down a level. I'm x3 plus x2 plus 2x plus 8. That's where we're at now. And now I can use the other one. Now I can use -2. Negative 2 on the outside. 1, 1, 2, 8. Bring the first one down 1, multiply across -2. Add down -1, multiply across 2. Add down 4. -8, add down 0. So again, checks out. It's always one power less. This is x squared minus x plus 4. And as I saw up there, that's already factored. I can't factor anymore. It's prime. Because the only thing left is imaginary roots. That's it. So don't forget the two things you plugged in. This is x plus 2 inside opposite. This will be x minus 3. Again, this is as far as you can go here because that's an imaginary root. So you can't go any further. You can't factor it anymore. And that's the lesson.